My name is Tessa Rogers, and this is my presentation for Chapter 34, Working Problems Backward and Inverse Problems. So to start, we should look at what complex problems are, and they use the analogy of a tree structure in order to understand a complex problem. The central problem being the trunk of the tree, and the roots of the tree becoming the material and energy and information that gets inputted into the trunk. Then with the branches on top, those would be the pathways to the solution of the problem. And because there's many branches, there could be more than one pathway, but it could also lead you to more other problems. Then they use the example of the parachuter getting stuck in the branches of a tree, right? So with the ultimate goal being to get to the ground. And so they have to work their way through the small branches to the larger branches in order to find the trunk of the tree, the central problem, and then ultimately get down to the ground. Using those two analogies, then we can look at the forward problem solving and backward problem solving. Forward being starting in the roots of the tree and working your way up to the branches and the solution, meaning the inputs down at the roots leading to the outcomes up into the branches, versus the backward problem solving, which takes you from the branch tips, the outcomes and the data, to the roots of the tree, which would be your inputs. And from there, we look at reverse problem solving, the simplest form being a problem solving strategy of working backwards, specifically when it comes to like a math problem, all the way through to the most complex, which would be called inverse problems. And they use them in astronomy and heat transfer. So working math problems backward, which would be the simplest form that was considered in the chapter, there's two strategies that they pointed out. The one was working backward to solve a problem. There was one answer, right? One goal, but there could be many ways to solve the problem. The example that they used was finding your way to a specific destination. You can look on a map and start at that destination and work your way back to where you would be in order to find the fastest route. The other one that they gave was the working a problem solved. So a lot of people use this to, like, they call it checking your work. The example that they gave was, after going shopping all day, you have so much money left over, but in order to figure out how much money you started with, you have to look at the transactions in the day and your money that was left at the end of the day in order to figure out how much you started with. And then inverse problems in engineering, the example that they gave that I connected with was the astronomy example. So the problem, or the complex problem, being Jupiter's surface conditions. What are they? And so then they looked at the different measures, or they would look at the different measures like light intensity and the colors, and they talked about also being able to measure the temperatures in order to estimate what the surface conditions of Jupiter would be, as well as weather patterns. And then my classroom applications for working backwards and inverse problems. The problem solving strategy would definitely work well with word problems in math. I have an example here. It says a spinner has 4 equal parts. One part is blue and one part is green. So what is the fraction of red and yellow if those would be the last 2 parts, if all the parts were equal? So you would start there with the 4 equal parts. The inverse problem was harder to come up with when it came to younger students because I teach third grade. So I use this example of finding an earthquake source, interpreting seismic data gathered from a geographic area. I don't think I would necessarily use this with my third graders, but because inverse problems involve advanced math, I just thought that this might be a good example for maybe older students. And then as well with finding the earthquake source, they could also figure out where it would go on the Richter magnitude scale from the measurements. Okay, in conclusion, inverse problems involve advanced and complicated math. That's a direct quote from the chapter. Working a problem backwards can be the fastest way to the answer, but it can sometimes be the only way to an answer. And engineers work backward to see the flaws in their prior design, so reverse engineering. And I'll just leave you with this quote from the chapter that I thought was pretty pertinent. It says, inverse problems are one of the most important and well-studied mathematical problems in science and engineering. Thank you very much.